Hi guys, and welcome back. In the earlier videos, we focused on taking a single logarithm and write it in expanded form. Today we're gonna backtrack everything that we did, but with a fresh set of problems. What we're gonna do, we're gonna take expression involving logarithms, and then we're gonna backtrack it to a single logarithm. So like put it in a condensed form. It would be nice if I read the directions, but I pretty much laid out what we're gonna do. So the directions read, use properties of logarithms to write each expression as a single logarithm. Okay, so we're going to use the product, quotient, and power rules to backtrack as a single logarithm. But now the question is, can we really backtrack to a single logarithm? What if it's a trick question? It's not. Okay, so then I'm like, how am I going to backtrack to a single logarithm? I'm really not sure. So when I'm not sure what I'm gonna do, I get a little bit frustrated. But that's not the word I'm looking for. What was the word I'm looking for? Yeah, I'm so mad at myself. Okay, I'm not. I just pretend that I am. So I'm like, silly logarithm rules, they make me so mad. So now I want to know, can I really backtrack to a single logarithm? So we're going to look at what's going on between the logs. Am I adding the logs? Am I subtracting the logs? If we're adding the logs, then when we backtrack to a single log, we're going to multiply the arguments. If we're subtracting the logarithms, then when we backtrack to a single log, we're going to divide the argument. But in this case, we have a sum of logs. So when we are adding the logarithms, we're going to go ahead, we are going to backtrack to a single logarithm by multiplying the arguments. Okay, I think I said too many words in an effort for me to break it down. Remind me to be more concise. Okay, so sum of logs, or if we're adding them, let's go ahead backtrack to a single log by multiplying their arguments. So that will give us logarithm base 8, and then we multiply the arguments. The arguments are 10 and 3. I know that you can multiply 10 and 3 in your head, but if we went straight to 30 for note-taking purposes, that doesn't really highlight how we got the 30. The worst thing you can do to yourself is just go straight to the punchline without showing your thought process. Remember, you need to use these notes to help you prepare for quizzes and tests and all that good stuff. Okay, product of 10 and 3 last time I checked gives us 30. So the question is, did we really write this as a single logarithm? We sure did, and we cannot evaluate this by hand. 8 to what power is 30? No idea. Okay, so one problem, two more to go. Problem B, we have logarithm base a of x, I forgot to open parenthesis, minus logarithm base a of y, close parenthesis, and we're going to add to it 2 times log. I'm going to go ahead and make it uppercase L, because when I do lowercase l with tired eyes, that looks like a 1. Well, right now that looks like a 1, so I'm not sure if it's a 1 or if I'm just tired. Probably both. So let's bring down the rest of the problem. So we have 2 times log base a of m. Okay, so we're going to go ahead focus on the grouping symbol. So we're going to go ahead subtract first. For the subtraction portion, how can I backtrack to a single logarithm? Can I even do it? So I'm like, silly logarithm rules, they make me so mad. And then I'm going to circle what I have, whether I'm adding the logs or subtracting them. So in this case, we are subtracting them. So to backtrack to a single log, we're going to divide the arguments. Okay, so we have logarithm base a, and we're going to divide the argument. So that will give us x over y. X over y. Okay, why do we divide? Because that was our quotient rule for logarithms. Let's bring down the rest of the problem. Plus 2 times log base a of m, plus twice log a base m. So then I'm like, okay, like I could backtrack more, you know. Silly logarithm rules, they make me so mad. And then same speech, am I adding the logs? Am I subtracting the logs? As you can see, we are adding the logs, but the thing is, we have a number in front of the logarithm. So at this point, we're going to use the power rule for logarithms in reverse to bring up that factor of 2. Whatever you're multiplying the log by, that is the hidden exponent on the argument. Okay, so let's go ahead bring that exponent up. So that will give us log base a of m raised to the second power. Now the question is, what if we wrote it incorrectly? Well, then at this point you can try to apply the power rule for logs, and then I'm like, how do I write it without the exponent? It's like, oh yeah, bring the 2 down and then multiply by the leftover log, which is what we had before. Okay, and what's going on with this term? That is being added to log base A of x over y. Okay, now that the logarithms, sorry for not leveling them up. Now that neither of the logarithms is being multiplied by a number, now we can ask ourselves, what is going on with the logarithmic terms? Are we adding them? Are we subtracting them? And as you can see, we are adding them. So if we are adding them, to backtrack to a single log, we are going to multiply their arguments, okay, or to write it in condensed form. Condensed form is the proper word, but for me it's easier to say backtrack, okay? For me to backtrack to a single log, we're going to multiply the arguments. So we're going to take log base A, and then we're going to multiply the arguments. So the first argument is xy, and then we're going to multiply it by the second argument. I don't want to confuse myself, so I'm going to wrap up the product. That is our answer. Let's go ahead, take our time, and simplify that product. So that will give us logarithm base A, and when we multiply across, x times m squared is just x times m squared. Y times nothing else is just y. The question or the guidelines were, do what you gotta do to write it as a single logarithm. We have a single logarithm, so we're good. We're going to pretend you can read that. So the answer is log base A of x times m squared over y. Okay guys, so that is the second problem. Let's go ahead, write our third and final problem, and then we're out. Problem C, we have 3 times log base x of 5. Let me go ahead and make that uppercase. Yeah, you cannot see that. 3 times log base x of 5, sorry about that, minus 1/2 times log base x of 16. Cool. So again, when I'm multiplying a log by a number, I usually write the log with uppercase L to avoid the lowercase l's looking like ones. Okay. So now the question is, how do we backtrack to a single logarithm? So I'm like, silly logarithm rules, they make me so mad. And I'm going to ask myself, what's going on with the logs? Am I adding them? Am I subtracting them? Yeah, we're subtracting them, but I'm not quite ready to write this as a single logarithm, because whether we backtrack to whether we have a sum or a difference, we got to make sure that neither of the logarithms is being multiplied by a number. So let's go ahead and use the power rule for logarithms in reverse to like bring the factor up. Whatever you're multiplying the log by, that's pretty much the exponent on the argument. So let's go ahead and bring those up. So the first part of the puzzle, that will give us log base x of 5, and now that 5 is being raised to the third power, minus log base x of 16, and that 16 is now being raised to the 1/2. Okay, so let's go ahead, simplify each argument, and then we'll worry about how do we backtrack to a single logarithm. So that will give us log base x. Last time I checked, who has a calculator, 5 to the third power will give us 125, minus log base x, 16 to the 1/2. I have no idea what that evaluates to. If you know what that evaluates to, more power to you, but I'm going to do it however I can. I'm going to remember that whenever we have a rational exponent or a fraction exponent, that is code for hidden radical. Since the denominator is 2, that means that the index should be 2. So we have square root of whatever we're left with, square root of 16 to the first power. So the moral of the story, 16 raised to the 1/2 is just a really fancy way to say what's the square root of 16. Okay, so we have log base x of 125 minus log base x of the square root of 16, with I think simplifies to 4. Okay, go ahead, verify that for me. Cool. So now I think now we are in good shape to now have a fighting chance to backtrack this to a single log. neither of the logarithms are no longer being multiplied by something, so we're good. We simplified the arguments. So now the question is, now how are we going to backtrack to a single log? So I'm going to ask myself, what's going on between the logarithms? Am I adding them? Well, let me vent out my frustration over here. What's going on with the logs? Am I adding them? Am I subtracting them? And as you can see, we are subtracting them. Okay, because we are subtracting the logarithms, when we backtrack to a single log, what are we going to do with the arguments? Yeah, we're going to go ahead and divide them. So we have logarithm base x, and we're going to divide the arguments. So first argument divided by second argument. So first argument divided by the second argument. And I think we're good. Just make sure that your fraction is reduced or simplified, and in this case it is. Okay guys, so I had promised you 3 problems. That was our third and final problem, and we're out. Thanks. Please keep coming back.